Okay, so now we are doing example number 3 of differentiating x squared by the limit process. By the limit process, we're going to have that f prime of x is equals to, or first we need to have f of x plus h, which is going to be x plus h squared, of which simplifies to x squared plus 2xh plus h squared. I hope you all know how to do that. So we're gonna have lim as h goes to 0 of x squared plus 2xh plus h squared minus x squared, dividing then all under h. So as per simplifying, simply x squared will cancel the other x squared and then we remain with the 2. Then our limit is going to be the limit as h goes to 0 of 2xh plus h squared all over h, and then we can factor out h and simplify. That implies that you're going to have that limit as h goes to 0 of h times 2x plus h all over h, and then the h above can simply go or cancel the h beneath. So we're going to have that this h here 1, h there 1, because it's affecting everything, and then we're going to have that, limit as h goes to 0 of 2x plus h, and then you're simply going to substitute h with a 0 because h is going to 0, which means we are now going to have 2x plus 0, which simply is 2x, and 2x, its differential is, the differential of x squared is simply 2x even by the power rule. So now having this one, we're gonna do the same thing, it's just arithmetic, f of x plus h. Not gonna do it, I'm just giving you a heads up. So it's gonna be x plus h squared plus x plus h as well. Each x has to have its h, and then you're going to expand. So after expanding, you're going to have something like x squared plus 2x h plus h squared from the first one. Then the second one to just be x plus h. I hope you're good on that one. And then after that, you're gonna do the limit process, and then just simple arithmetic, cancel out, then plug at the end of the day. So I'm gonna do this one now. This is number 5 like this. So what is f of x plus h? F of x plus h, it's gonna be 1 over x plus h. So we're simply gonna do that. So now we are going to have that the space is small, but f prime of x is going to be limit as h goes to 0 of f of x plus h is this one again. So it's going to be 1 over x plus h minus 1 over x again, and all over h. So for us to be able to solve this, we need to simplify the above by making it first a single fraction. So first we are going to find its lowest common multiple. It doesn't have, so whatever, we're simply going to multiply them, or we can say it is their product. So we're going to be it, and then x plus h into that is x times 1 is going to be x, and then minus x into the beneath is going to be x plus h times 1. There's going to be x plus h. So then, remember, is everything over h. Now you're going to have the limit as h goes to 0 of when you simplify, removing the brackets, it's going to be x minus x plus h over x times x plus h. Remember, everything over h. Then we sort the above. Sorting the above, x will go with x. Then you're going to have limit. We're going to have limit as x as h go to 0 of h over x plus h, and then all over h. So this is simply the division of fractions. Then when dividing, what happens? You invert the last fraction and multiply. What is our last fraction? Our last fraction is the small h, which is at the end, and it is alone. Therefore, is going to be the limit as h goes to 0 of h over x times x plus h times 1 over h. Then h into h is 1. H here 1, h here 1. Then you're gonna have, we are simply going to have that the limit as h goes to 0 of 1 over x times x plus h. There's nothing we can do now. We can simply plug h. Plugging h, we're going to have 1 over x plus 0, which is simply be 1 over x squared. That will be your answer. I hope we are good. That will be our answer. That's how it is. It's simple. It's quite simple. It's not hard. You just follow the steps. You can't do it once. You have to do it, practice it many times. So f of x plus h, for number c, is going to be root x plus h. So as for the limit, f prime of x is equals to limit as h goes to 0 of root x plus h minus root x all over h, all over h. So simplifying, there's nothing we can do to simplify. So we're simply going to have what is it? This one is not doable. I messed up some. Okay, right. No, I made a mistake. Sorry about that. Let me do it first. I'll get back to you, and then I'll give you example questions. So thank you. Bye.